of the drum above the surface, and you can calibrate both sides so the pressure is the same on each side. Hand drive through. This 2-inch round stock, 2.5-inch round.
Do you do all kinds of things? Or are you a whip cracker?
Yeah, I'm a whip cracker. I've built every part on this machine more than, I've been working here 21 years, so I've done it all. I'm the shop foreman right now, so.
It sounds like it would be a good life because you're building things that are
yeah, and we're putting
real.
our name on it, so we take a lot of pride in what we do. What these are right here, these end up being the top rails for the floor model presses.
Oh, right.
At this point, he's got them drilled, outside access hole, and the inside holes, and the threaded holes for where the bed level and eccentrics go on. The bosses where the upper uprights and the upper pressure assembly bolts on have been welded on and capped, and that type of thing. After they get done like that, caps are welded on the ends, and then they go over to this fixture over here, which is what all the frames are built up in. Top rail ends up laying up in this channel. The legs are put in here like this and all clamped up. And then they're welded, and then the whole thing is turned over, and it's all reclamped again, and it's welded on the second side, and then the feet are put on and welded.
Well, you don't get too many with a wobble. I know that.
And
That's
so
incredible.
some of the parts made for that, all the legs and whatnot are cut, drilled, and they're all stacked under there. The baffles for making the drums and whatnot, those are stacks of baffles that are placed inside the large diameter pipe and welded in. So there's just a variety of parts, different places through the shop, depending where they need to be used. Saw. Most of the stock goes from the rack in onto this table, and then it's cut off with this metal cutting.
So that's a cutoff saw for metal. What kind of a blade does he use? Like a carbide?
No, it's not a carbide. It's called a bimetal blade. Teeth are really hard on it, not as hard as carbide, but they're about Rockwell 60C hardness, which is pretty tough. It's called bimetal because the upper part of the blade is flexible, so it can run across these bands. So it's one continuous band. And if you come on this side, I can open up the guard on it.
Oh, it's like a sideways bandsaw.
Yeah, just like
on
a
a
bandsaw,
big scale.
It's called a horizontal bandsaw. So this blade runs around, these wheels drive it, and then the guides, which these are the guide arms, guides are down here, take the blade and make it conform to a straight shape where it's sawn through the part. So blade goes from running horizontally to running perfectly vertically in that area. And then it goes back around the guides. So. Let's see if I can find a little piece of stock and cut it. This piece is 1.5 inch square solid steel. And if you've ever used a hacksaw, you can probably know it takes quite a while to cut through that. So it takes about that long. So most of the parts start there because we saw them close to the length we're going to be finishing them. If this was a part, it might go into the lathe next and be faced, so this end was nice and square to the rest of it. Might go to the mill, and holes drilled in a certain distance apart. Holes could be drilled and tapped, put a thread in it. A lot of different things it could conceivably be from that point on. So.
I'm feeling guilty because I know it's your quitting time. You need to get
no
home. Zip.
This is the welding area back in here. We have capability to do MIG welding, which is metal inert gas. It uses a filler wire. Comes on a spool, it's 45 thousandths diameter wire. It comes all the way out the cable and on the end. So
All right.
when this thing's up and running, it uses a shielding gas. It uses CO2 shielding gas, which also comes out. And if I was welding this joint together, if it was all clamped up, basically I'd just put this like this, put my helmet on, pull the trigger, and it would start welding. It'd melt the parent material and deposit weld into
And with your experience, you'd be able to tell exactly.
I could tell what was going on. If it was
yeah.
hot enough, and I'd be able to watch the joint and run the weld right up it. Nice thing about this, the way a lot of people are used to welding is with a stick welder, which you use electrodes like this that you put in a holder.
Right, I've seen that.
And you'd strike an arc, and then you'd bring this along, and this would melt up as you form the joint. One benefit of the MIG is it's continuous wire, so a lot of times you use these, and then you run the last one. You may run out of rod before you get done, so you have to start over. Or this produces a lot of slag. It doesn't have the shielding gas that this one does, so it has what's called flux all around the rod. So as you burn it, it forms a coating on the top of the weld to protect it from the oxygen, to keep it from getting porosity in it. So as you weld, after you weld, then you have to chip all the slag off. So this is a much cleaner weld and a stronger weld than.
That seems real high tech.
Yeah, it's a really nice way to go. The other capability we have is TIG welding, which is tungsten inert gas. It uses a tungsten electrode. Tungsten is what's used. Most people know of it being used in light bulbs. That's a piece of metal that'll burn white hot in a light bulb and last a long time. So what happens with this is you use a shielding gas also, which is in that bottle back there, and it comes out the hose, and it's used for finer, delicate work. If you're working, you don't want BB splatters, or you're working in a confined area, you can use this, and basically use this one with a pedal. You can control the amperage to the torch. It starts the gas flow, and if I was going to weld with this, basically it doesn't have filler wire, so.
Back to welding.
Okay, so on a TIG, it's used for more delicate things, and a lot cleaner weld. There's no splatter at all with it, no BBs, as we call them, which are the little pieces of molten metal that fly off as you're welding with the other processes. It'll stick on different things. So if I was welding these two pieces together, I'd basically have the machine on and strike an arc to establish an arc between the tungsten and the metal, and it would melt the metal. Then I'd use a filler rod. I'd have my helmet on, of course. I'd use my filler rod, and I'd dip it, and I'd move ahead, form a puddle again, dip in. So I have to hand feed the filler rod in this case.
You don't have to clamp the two pieces together? Or
Well, yeah, normally if you're welding, you'd have everything clamped up, typically. If you're just welding flat pieces, typically without clamping, you'd actually set them like this, because as they heat, they'll draw in together like this.
Oh, really?
So you have to allow for expansion unless you clamp them. If you wanted to clamp it, normally you clamp them down. You put a couple clamps like this and clamp it so they don't rock up and move apart where you need them.
Are there any parts on our press that might have been welded that way?
Yeah, let's see. On the very ends of where your 1.5" blocks on the top, the 5/8 by 2 comes up and meets the end of your block. Actually, it's like this. The little piece across the 5/8 right there was welded with the TIG weld. I can show you on the tabletop too, so everybody knows what it is. Most of the welding done on yours was done with the MIG welder, though. Done with this machine over here.